didn't start yet. We've graphed sine and cosine and secant and cosecant and tangent and cotangent. So up to this point, we've graphed the functions with all their transformations as well as their reciprocal functions, right? We have not yet graphed their inverse functions. So that's what we're doing today. But we're going to do this mostly together, and it's going to be fine. Most of you guys could probably do half of this by yourself. So arc cosine, arc sine, and arc tangent are the fancy names for the inverses. So like arc sine is the same thing as on your calculator, sine to -1. It's just a fancy name, okay? So let's not, freak out. Just arc sine, arc cosine, and arc tangent. So on number 1, we're just going to graph y equals sine x. Good old, plain old y equals sine x. So at the origin, where should there be a point? At 0 or 1? 0. And then what happens at pi over 2? To the maximum of 1, and then at pi, back to the 0, and then 3 pi over 2 at -1. And we could go backwards. Right? That's like the basic sine curve, right? That's the parent function. There's no extra stuff going on here. Nuts. I'm not going to make you label all of this today. I think we've talked about it enough. Everyone okay with the sine curve? What is the domain? All real numbers. You can use whatever x value you want. You can write that as all real numbers or negative infinity to infinity, ever you feel like. And what is the range? -1 to 1. Again, you can write it with inequalities or interval notation, however you feel. You guys talked a bit about inverses in Algebra 2. So you do inverse, you take the x and y's and you interchange them, right? So if you do x equals sine of y, that is the inverse. And so that is arc sine. So we're going to go through and graph arc sine. Now, when you graph a function, if you have a set of points, you just interchange their x and y values. So you will notice that the axes have the appropriate scale on them for you. But if we're going to graph y equals arc sine, we can start at 0, 0. Well, if you interchange 0 and 0, you still have 0, 0. There's still a point at the origin. Then, like this point is at pi over 2, 1. Well, that means now there'll be a point at 1 pi over 2. Because you interchange the x and y coordinates. Then this point right here is at pi 0. So now there'll be a point at 0 pi. And 3 pi over 2 -1 would be -1, 3 pi over 2. And continuing on, you'd have, instead of 2 pi 0, 0, 2 pi. Yes. Nope. So what's the domain of arc sine? -1 to 1. What's the range? All real numbers. Is arcsine a function? No. Why not? Vertical line test. That's good. Sometimes when I'm teaching this, people go, "The what?" And I'm like, "The vertical line test." So if it's not a function, that presents a problem. Of course, presents a problem. It would be too easy if it didn't, right? So I don't expect you to be able to answer this question. Like you wouldn't know, so I'll talk about it. But is it possible to define a new function from the graph of y equals sine of x whose inverse is a function? I wouldn't expect you to know, but the answer is yes. What you can do is you can restrict the domain of the original, and that way the inverse of that restricted domain graph would also be a function. All right. We can talk about what that means on the next page. No. No, you are not. I wouldn't be like, ask you that, and you'd be like, yeah, sure, Miss Holtman, that's what we're going to do. Like, that's not. No. So, it is possible to define a new function called sine. See how the capital S? That's actually important. Whose inverse is a function. So y equals capital S sine of x if and only if you take the original parent function and restrict the domain from negative pi over 2 to pi over 2. Okay? So the values in the domain of capital S sine are called the principal values. All right? This is why if you choose to use the inverse in your calculator, all right, it's totally fine. But if you're trying to use inverses before in your calculator, and we do things in degrees or whatever, you might have gotten an answer like negative 90 instead of 270 degrees. That's because your calculator inverse is programmed with the restricted domain. All right. So we know that negative 90 degrees and 270 degrees on the unit circle are coterminal to each other. But your calculator is not going to give you 270 degrees when you use the inverse because it's not in this restricted section. Right? It'll refer to it as negative 90. You could find the coterminal angle by adding 360 degrees or adding 2 pi. All right, but just know that your calculator is programmed with this for the inverse. Okay, that explains some answers you might have gotten. All right, so it says indicate the graph of the inverse, capital S sine of x, on your graph on the first page of the worksheet and fill in the chart below. So I'm just going to, on the front page, we're going to draw a box around what section we're using. So negative pi over 2 to pi over 2, that means I'm using this section of the graph and only that section when I'm defining y equals sine of x. So its domain is negative pi over 2 to pi over 2. I mean, they already told you that literally right here. And the range is still negative 1 to 1. So the only thing we've changed is we just tightened up what part of the graph we're allowed to use. On that part, the domain part. Because that is this specific function, y equals sine of x, the one that's been defined so that when we do the inverse, it's actually a function 2. So the curve altogether is the normal sine curve, but the part I drew a box around is the part of the sine curve that we're defining as capital S. We haven't graphed the inverse part yet. We're going to do that in like 2 seconds. We're going to draw another box is what we're going to do. All right. Everyone good with that? Yes, maybe? All right. So then arc sine with a capital A is that restricted part of the function. And so again, I'm going to draw another box. If the domain here was negative pi over 2 to pi over 2, that means the range of the inverse is negative pi over 2 to pi over 2. So in that case, for the inverse, we're only using this section. So again, the domain here is negative 1 to 1 still. But now the range is negative pi over 2 to pi over 2. Now the inverse is a function, right? It passes the vertical line test. Yeah, I know. Yes. Questions so far? Okay. I want you to then, on your own, with a friend, I don't know, I want you to attempt the cosine section. You guys know how to graph cosine? I'm pretty sure you can graph the inverse relation, figure it out. If you flip the page, it tells you what to define the domain as when you restrict it. So you can go through. I want you to try to do the next 2 pages. Again, you can totally consult someone else. I'll show you the answer in a second. All right. Looks like most people are done, so let's look at it. Make sure you have it. We have cosine. We all know what cosine looks like. We know the domain and range. It's arc cosine with two C's. And then I have highlighted the section from 0 to pi, which is what they've defined cosine to be on the restricted domain. So it's not negative pi over 2 to pi over 2. It's 0 to pi. All right. Everyone go with that part. So then for the inverse, here's your inverse cosine relation with arc cosine defined from 0 to pi in the range. Everyone go with that. Any questions on where any of that came from? Yes, we're good. That should say y, not x. All right. All right. Well, so then the last one I'll do with you because it's tangent. Oof, hate that. All right. So on tangent, we just learned how to graph tangent last week. So remember, the tangent period is pi, not 2 pi. So actually, yes, this is set up nice for us, but we'll need to use points in between here. All right. So tangent at x equals 0, tangent is 0, if you recall. And then at pi over 4, it's 1. At pi over 2, there's an asymptote. And then at 3 pi over 4, negative 1, pi, 0, and then 1, and then an asymptote. This keeps repeating. Same thing going the other direction. I have to draw a bunch of these. Ugh. So bad at it. It's just so busy. We talked about this briefly last week, but the domain is like complicated to write out. So we're going to write it out. But it's not as simple as what we've been doing, right? The problem is that we have an asymptote at every odd integer pi over 2, right? At 1 pi over 2 and 3 pi over 2. So we say that, we can say that it's all real numbers except n pi over 2, where n is an odd integer. Doesn't really fit in the box. But what's the range? All real numbers. So it's all real numbers except n pi over 2, where n is an odd integer. Because it has to specifically be odd and has to be an integer, because not, it would be some random decimal or something. So we have to be very specific. And of course, the inverse is going to be called arc tangent. All right, now this is where you have to be very careful. You really need to make sure you're looking at points and you're interchanging points so that you don't do arctangent backwards. Okay? So yes, we have point on 0, 0. That's nice. Great. Being tabulous. Then we had a point at pi over 4, 1. So we point at 1 pi over 4. There was an asymptote at pi over 2, so that means there's going to be an asymptote that's horizontal at pi over 2. Then at 3 pi over 4, it was negative 1. So it means negative 1, 3 pi over 4. And here, and again, it starts repeating. But if you're not careful, you'll do this wrong. So this goes this direction. Really bad at drawing the curve sideways, especially. So now the domain is all real numbers, because you can use whatever x value you'd like. And the range is that big, long mouthful. All real numbers except n pi over 2, where n is an odd integer. The whole thing. Is a relation function? Still no. Still doesn't pass the vertical line test. Now we have, curves stacked on top of each other, so that's for sure not going to pass the vertical line test. And yeah, you can still restrict the domain. So again, they restrict it for you on the back, and something flipping back and forth. It should be familiar. So for tangent, they restrict the domain to negative pi over 2 to pi over 2. Make sure you understand that it's not inclusive. Why are those symbols not equal to? Because they're asymptotes. All right, so that's intentional. So we're using this center curve. That's not arctangent yet. And then so for the inverse, your range is negative pi over 2 to pi over 2. Again, not included are those endpoints. So these are a lot easier to write now. The domain is negative pi over 2 to pi over 2 instead of being super long complex. Everyone with me so far? All right, I'm not going to make you do the next page. The next page just takes all that stuff you've already written and makes you rewrite it, so I'm not going to make you do that today. All right, it's literally a summary table of what the domains and ranges are for all of those things. We've already written them. We're good, okay? So we're going to do the last page. I'm going to do a couple of examples from the last page, okay? If you have a unit circle with you, you can get it out, and if not, you can look at mine. I'll have it on the screen because we're going to use the unit circle to answer these questions. If mine will open. Just thinking about it. It's spinning its wheels. All right. All right. We have used the unit circle to answer questions so far in this unit and the last unit. So I could very easily ask you guys, what is the sign of pi over 6? 1/2. I should also then be able to ask you the opposite. I should be able to say, what is arc sine of 1/2? Arc sine. It's just the inverse, right? So if sine of pi over 6 equals 1/2, arc sine of 1/2 equals pi over 6. All right, so it's doing the opposite. If you're asked for the arc sine again, that's not the reciprocal, right? It's the inverse. So you're looking for then, you're given the y value of the coordinate, and you're looking for the rating measure that corresponds to that. Okay, now here's where this inverse stuff that we just talked about, everything being restricted, matters. Technically, if I said what's arc sine of 1/2, there are two places on this unit circle where sine is positive 1/2, pi over 6 and at 5 pi over 6. Okay. However, all of these questions are going to be talking about the restricted inverse, and that restricted inverse is from negative pi over 2 to pi over 2. So I can't include 5 pi over 6 in my answer because it's not in that domain or that range when you do the inverse. So I'm going to do some examples to practice. They're on the last page. Okay, so we just did this one. Arc sine of 1/2 is pi over 6. Right, sine to the negative 1 still means arc sine. Same thing, right? So arc sine of negative 1/2. If you look at the unit circle and you're looking to see where sine is negative 1/2, that would be at 7 pi over 6 and 11 pi over 6. Here's the problem. Both of those numbers are not between negative pi over 2 and pi over 2. All right? They aren't, right? Negative pi over 2 is negative 90. Pi over 2 is 90. So 210 and 330 are outside of that interval. So when you're answering these questions, if you're especially sine questions, you can't think of these values as what's listed on the actual unit circle. You have to think about them as the negative interval and angle starting from 0. So like 11 pi over 6, that's the same thing as negative pi over 6. 7 pi over 4, that's the same thing as negative pi over 4. 5 pi over 3 is the same thing as negative pi over 3. And 3 pi over 2 is the same thing as negative pi over 2. It's like counting backwards, right? You have this top quadrant, and I'm just counting the same way, going the opposite direction, okay? So if I ask you what the arc sine of negative 1/2 is, the answer is going to be negative pi over 6. If you think about this unit circle and those restricted domains, then if I am doing arc sine, I can only look at the right-hand side of the circle, right? You shouldn't even be looking the left-hand side. If you're doing arc tangent, again, you should only be looking at the right-hand side of the circle, not the left-hand side. If you're thinking about the y-axis splitting it in half. For cosine, though, arc cosine is from 0 to pi. So you should only be looking at the top half of the circle. You should not be looking at the bottom half. All right. So arc cosine of 1/2. Where is the x coordinate 1/2 then? Pi over 3. Again, it's also the same at 5 pi over 3, but that's not in that restricted domain. So pi over 3, it is. Arc cosine of negative 1/2. Again, cosine is defined from 0 to pi, so you should only be looking at the top half of the circle. So where is the x-coordinate negative 1/2? 2 pi over 3, so that's the answer. All right. Arc tangent of 1. Well, tangent, remember takes a little bit extra effort. We have to divide x and y. But I gave you easy ones, 1 and negative 1. Right? That's where something's divided by itself. So where is arc tangent 1? Pi over 4, right? Because you'd have y divided by x, and that'd be 1. The next one, where is arc tangent negative 1? Yes, but is that in the restricted domain negative pi over 2 to pi over 2? It would be the location where 7 pi over 4 is, right? But it has to be the coterminal angle, it has to be the negative angle, so it has to be negative pi over 4. All right, the rest of these look complicated, but they're not. They're just like order of operations questions. So the first thing here, what is the cosine of pi over 2? Just cosine of pi over 2. 0. So then what is the inverse sine of 0? So where's the y-coordinate 0? So it's at 0, pi, and 2 pi, right? And the only one of those numbers that's between negative pi over 2 and pi over 2 is 0. Yep. So the next one, what's the tangent of pi? 0. Note that was a lowercase t, so it doesn't matter where we're on the circle, right? And so then what's inverse cosine of 0? Pi over 2. All right. Again, we got to do some more steps here. Inverse cosine of 1. 0. Inverse cosine of a half. 5/6. 0 minus pi over 6 is negative pi over 6. And so then lowercase cosine, just what's the cosine of negative pi over 6? Radical 3 over 2. Because negative pi over 6 would be starting at 0 going the opposite direction.